So welcome all of you to my first ever presentation here at Hackware. Finally, I got something down enough to talk about. All right, so normally you would think origami is for a decorative purpose. Like I'm sure all of you are familiar with like folded cranes or paper airplanes, all those patterns, or cut and fold snowflakes. Well, but this time we're serious. We're talking about the scientific and engineering and mathematical and also fun applications of origami. I'd like to bring to your attention three named algorithms that I have used so far, and I thought they were just interesting to share so far. First off, foremost, the Fujimoto algorithm, which performs a really interesting thing, I believe. Have you ever had to like fold a letter into an envelope and you had to like kind of jangle it a little bit in order to put it into thirds? Well, with this Fujimoto algorithm, which is rather obscure, it's so obscure that there's no Wikipedia article for it. It will allow you to fold any piece of paper, any sheet, well, it could even be a block if you're strong enough, any sheet into thirds, fifths, eighths, 17ths, 36, 131sts, perfectly every time.
Wow.
In a
No, that the last time I needed to fold something in 100 and...
Excellent. And then when I saw this, I was like, oh, holy smokes, everyone needs to know about this. So here we are. The Fujimoto algorithm is directly tied to the Moira fold. I'm sure some of you might have heard about this before. It's used in satellites. And finally, the little half-completed mess over here is a halfway project of the domain folded font. It's basically a way to create, normally you would create like words onto paper, but what about creating the words with the actual paper? We'll get to that in a bit. But first, some acknowledgements. These are the three lovely people whose papers contributed that I've read a while ago and I studied in order to help develop these applications and see what I could do. Yeah, feel free to take a picture because there's three of them over there. Each one standing on the shoulders of the last. Fujimoto Shujo, he hasn't published much papers, but he is, I believe he's probably the first ever origami engineer, the first person to actually use origami for something that is not decorative. All right, so let's get right into it. So much talk about the Fujimoto technique, and then what exactly is it? First of all, I'm sure all of you computer scientists know about the binary numbering system, basically representing numbers as like ones and zeros. But the thing is, first I'd like to familiarize all of you with fractional binary representation. And I know this is not exactly the fixed point or floating point Mantis exponential that you will be familiar with, but bear with me a bit. It's basically about the same, but in like on the right side of the decimal place. Let's say if you take like a 3, for example, how do you form 1/3 into a summation of like a half, one quarter, 1/8, etc.? Whether you fill in the blank with a half or not, then you put a 0 and 1 accordingly. So basically, it forms this infinite series. Now, as you might notice that for the base 2 numbers, like 2 and 4 and 8 and 16, they form just basically definite binary numbers. However, for the odd ones over here, like 3 and 5 and 7, we'll get to that in a bit, they are recursive sequences. Now this will be interesting. That means there will be some aspect of like estimation or iterative algorithm over here. So pay attention to these sequences over here for a bit, and we'll get into it. Yeah. This is basically the premise. I wanted to fold like paper for origami into thirds, and people say like, oh, it's simple, you just get a ruler and measure it. But I'm like, what if I don't have tools? What if I'm just in the MRT, like sitting here and I'm like in a lecture, I'm like, okay, wow, wow, my lecture is just droning on. Let me just fold my notes into a sheet. Oh,
Wow.
yeah, this lovely little zone over here. So that's when I started like kind of looking into this. Right, so cut to the chase. Here's the actual algorithm. Let's go this way. Yeah, all right. So I've got over here some sheets of origami. If anyone would like to take some on the desk, pass it around if you want to follow along. Because I urge you to follow along so then it gets better with muscle memory. So then you can get back to this when you really need it. Okay, I've got one over here. Yeah, here's an example over here. One of my first ventures, no markings whatsoever. This is a piece of paper that was folded perfectly into nine even pieces.
And it's still recording in fold to, it's still recording in fold to, is it like alternating fold to fold it up? Like what you're doing right now, you can do that.
Oh, accordion, yeah, accordion. Well, I just have to do it accordion fold. But you do it like all towards you, all down folds, all down folds.
Can you make a fold that can reduce the dignified in a specific parameter?
We're getting to that next, actually. So good eye. Yes, and this is an iterative presentation. So first off, if you go back to these, wait, how do I? Yeah, there we go. So first off, let's say if we want to fold something into perfect thirds, it will be like 0, 1, 0, 1, 0, 1, etc. ad infinitum. So here's how we do it. Remember the 0, 1 sequence. Simply get a piece of paper, and then start by folding it in half. And it's just in half. That means bring the right edge all the way over to the left edge, and then we're done. It's half. Just kidding. Right, half, and then that is a 0 in the sequence. Basically a right fold. Is it? No. This is the initial. Whenever you start the Fujimoto, you have to fold in half first. You can actually like do a guess, but the thing is, this method is like a no-brainer. And then, starting with 0, you have to fold the right side all the way to the center crease. Oh yeah. This. And you don't have to fold it all the way. You can just make a little notch at the top so you don't have crumply paper. And then now it's in quarters. Great. And then bring the left side over to the previous notch that you made. It's always the last one. So right over there. And then this amount over here, it's starting to form kind of threes, but we'll just repeat it. Like all great computer programs, we just iterate. That was one iteration. And then we do it again. Right, and then left. I wish I had a overhead projector. And it'll be like professor style. Yeah, now it's starting to take shape, and then to be pedantic, I just do it again. Hold it to the last. Yes. And we do that again. And we fold that over itself. And then, yeah, look at that. Once you fold those together, then there you go, perfect threes. And then we didn't have to use a ruler at all. Normally, you have to repeat this entire like a recursive process about 2 or 3 times, and then Bob's your uncle.
How can you be so sure that Shinzo Fujimoto is the first to come up with this algorithm, considering Origami has been in platform for well over
that's a sticky thing about history. That's the first documented instance. Also, do note that to blow your mind a little bit, human history, documented human history, has been around for like what? Only like 100,000 years or so, 10,000 years. What happened to everything before that? We just don't know. We might as well not have existed yet. But as far as I know, Shuzu Fujimoto is the first person who have done it.
always comes down to math, doesn't it?
Yeah. It's either math or it's not. That's binary math. Yeah, so here are a few more examples that I brought along with me. I've got one that was done in a perfect sevenths. The red marker over here is the first pass. First I do like a right fold, left and left. And then green one is second and the blue one is third. Usually it will converge within 2 iterations. And then once you've singled out, yes, you got your 1/5, you simply do like a half and quarter folds for the remaining, and then you've got the rest of the parts of it. And also something that's interesting about this process is that it doesn't only work for like lengths, it also works for angle sections, which is a little bit interesting because I'm sure you might have remembered that back in high school, angle trisection is impossible if you do it with only a straight edge and a compass. So now that you've managed to have a paper method with no other tools to create like 36 sections of a circle, everything's amazing.
If you fold half, when we pair, right? For a complicated design, exactly, with the fact it was no
Oh wait, oh yeah. Oh yes, that's the thing. That's the basic premise of it, but exactly how you move from a single segment to the others, we'll get to that in our demo section. Because if you fold sevens, you can't fold it half all the way because you might have noticed that you've got 6 remaining segments, so then you're going to have to do Fujimoto's to get thirds. Or you can approximate it.
Basically, not all the folds are final folds. Some of them are just approximate. You can get closer and closer to the final fold.
Yeah, exactly. But something that's other than just paper folding, because when it starts to converge, then you can't really be sure. I'm just imagining that, I bet, it has not been developed at this stage, but I bet this thing has some kind of like analog computer aspect to it. Stay tuned for the next talk.
Would you say it's like binary search?
Yes, exactly. It is a binary search-like algorithm, but the thing is, it's not binary. If there's any, would you say it's
converging algorithm?
Yeah. I think it's. I'm no computer scientist, but binary search. I have a feeling it converges faster than a binary search, but we're going to have to check that out next up. Yeah. Yes. How's everyone doing with the folding so far? Oh, it looks pretty good. Has everyone managed to get it so far? Well, we can go back. We can sit around in this nice open space, and then we could learn this essential office skill. Right. Now the star of the show. Oh yeah, the star of the show is the reason why we learned this approximation method is because I wanted to be able to, if I had like scrap paper in my hands, or if I had like some big sheet that I don't want to carry like a folder with, I want to fold it to my pocket, but I don't want to like mangle it with like a reversion or circle. I want to hold it, just grab it, and then just pull it apart, and then it opens like that. So this is quite helpful because imagine we have a map or you have a diploma. Don't fold your diploma. This is the opposite of what I wanted to done with my diploma. But yeah, how I came up with this is that bunch of them around over here. Oh, there it is. What is that? The reason why what propelled my search in the first place was I went to a traditional career fair, and you know how you have to like send out like resumes to everyone. Well, I thought, what if my business card is about this size, and then I tell them, if you want to know more, don't scan anything, just open it, and then it's my resume. Wow. It's quite good. It's work out because I didn't have space. Yeah, so I'll show y'all about how to do the Moira fold, but as you can see over here, such an impressive. Yeah, it's
It goes invert outwards, and then the picture is outward invert, and it keeps alternating between the two, and then the other side of folds is just regular alternating pattern.
Yep, that's a good observation. That it's not like the sort of origami that once you fold it, then you're done with it. You have to go back over and increase it alternately, which is quite painstaking. So that's why you going over with a pen or a knife would be good. The main reason why we learned the Fujimoto first is because this fold, the top requires perfect fifths, and then the side requires perfect sevenths, but they're oblique. We'll get to that in a bit. So right now with your new knowledge about the Fujimoto algorithm, if you have a piece of paper, it can be rectangular, it can be a sheet, it can be the square sheets that I handed out. We'll learn you how to create the famous solar sail or satellite solar panel fold. How it is basically just, this is a nice A3 size. We will fold in fold in a 4, in a 5 like this. Yeah. And then you have a little strip of paper. Yeah, I'm going a little fast just for demonstration, so that I'll go slower if you all want to try it out before. So now you're over here. We do the Fujimoto method to get 1/7 on the right side and 1/7 on the left side. You don't need to do the intermediate. The intermediate will come out by itself. So you make little notches here. Now on the left side, you draw a line that just drops down right angle to the top. And you divide that in 3, also like Fujimoto's method. You grab the upper right side, and then you bring it down to the lower third, and then that usually creates a oblique angle, something like that. And then you fold up the right side in such a way so that the top side of this paper is parallel to the top side of this paper, so then you get like a little C action going on. And if you do it right, this method will basically bisect this section into 3 pieces, perfect pieces. You know you did it right when this side will perfectly fit on the other side of that. And then turn around and continue this. And there you go. You have your Moira fold crease pattern. Here comes the hard part. When you're done with all of that, you go through all of your little crease marks again. And then whenever there's a little smiley face, you say, oh, the smiley face means it's time to lay back. This part is a mountain fold, it needs to push away from you. And then you simply follow, you want to pass along all the hacking, so you follow along this way. It's mountain fold all the way along. And after that, you do basically an accordion recrease. Mountain, valley, 6 more times until you get the final crease pattern. Push it in a little bit. This is live action replay, it's much accelerated. This is especially human, that's why the paper through that kind of soggy right now. Now that you've got it all wrapped up, you squish it. Make sure it doesn't move anywhere. Because if you move it back into the original accordion fold, then it kind of breaks up the alternating fold pattern. Now when you're done, just flip it around, push out these little dog ears. You got it? Just like that. time you have something that you want to carry with you, instead of having to like fold it around, you just say like, oh, ta-da, ta-da, ta-da. And so obviously, I'm sure this has a lot of applications for a sunroof, or for a solar panel in space, or storing cheat sheets in your pocket, or fiddling around in an educated manner.
Passport.
Your passport, yes, your passport, or like a magazine gatefold. Yeah, really, this is the future in a sheet of paper.
I mean, you could probably make a paper where you can store sheets of paper when the creases are printed on, so you can write outside in between the creases. And then people can fold it into storage. And when you take it out, the creases don't affect the text on it that they did there. And then they roll out.
That's a great idea. That's literally reading and writing using the words.
Although, getting file infinitely,
Oh, okay.
the amount of folds, like the amount, like, because it's 5 and 7 folds, is that necessary, or can it be in a specific set of folds?
That is related to the assigned homework. I'm just kidding. It's just for your own exploration. Yes, 5 by 7 is the desired aspect ratio, but in reality, you can actually do it by 8 by 8 or 4 by 4, but it will be very sharp. It will look more like a stick rather than a little packet over here. You can try like any odd amount, like 7, 11, 9, 11, never forget, 11, 36. Just change the aspect ratio of the little parallelogram and however it turns out. So I urge all of you to try this out and wang jangle it a little bit.
It doesn't, the creases don't like stretch the more you fold it, right? Because the way, one of the issues with folding paper on itself over and over again is that the thickness increases and the crease stretches even further.
Yeah.
Whereas in this case, I don't think it works.
Yeah, exactly. That's a good point. That's probably the reason why it's so hard to like just wrangle it back in position.
Yeah, because if you were to try to do it with solar panels, then we need the hinge to sort of expand in order to do the folds. But with this method, all the hinges are the same length, regardless of how many times it folds.
Yeah, that's because this is a continuous
Yeah.
sheet. But yeah, the original plan of this thing, if I had more time on leave, you would have seen the stained glass origami. It's literally a stained glass sheet of conductive glass turned into a little crinkly Moira fold over there. But I did not have time for that, and also transporting here would have been difficult. Yeah. So for now, let's go fold some Moira folds. Last thing, this is a little bit of dark magic that I came across. Feel free to scan the QR code. It has a link to a GitHub. Dr. Eric Damani's GitHub, where he implements the SVG generating program of this from a simple text.
Have you seen the black lines and cut lines?
Yeah, black is cut lines. The gray is an even. It's not quite visible, but black is hard cut lines. They don't go all the way. The purple lines fold alternately. That means it'll be like valley, mountain, so on and so forth.
Oh.
And the result would create basically a font like this in space. The problem is it's very janky, like you see the one over there. So you need to tie it down, but the fact that this even works, when I read the paper, I wondered, how the heck did they come up with this?
Imagine getting a script that's made like this. And then how much people
By the way, your QR code didn't scan.
Ooh.
I know why. So maybe a public announcement, because not a lot of people know that, but each QR code has a row of 4 pixels of white around it, and that is an integral part of the QR code.
Yeah.
If you crop that out, it doesn't work.
Oh. Yeah, I was wondering, like, wait a minute, this is too
Somehow,
close.
whatever this magic is, it worked.
Okay, yeah, sure.
So,
To be fair, I wouldn't be surprised if there's programs that work around that.
I'm sure this is a common mistake that a lot of people
Yeah.
do.
You probably it's probably because of the relocating space.
Yeah, you need, there needs to be space around.
Yeah, I think the software probably adds retroactively that space out.
Yeah, so you can also put the website, lets you put in the text, whatever you want to put, and it tells you how to fold it to get that.
Maybe you could read it, right? If you drop it in the Telegram group.
Oh yeah, sure.
Oh yeah, the link drops
So
the
that.
link.
All right.
So the limit like it's not a search, right? It's not a J or anything like that.
It's not a
Like
The algorithm for making this?
yeah.
It's not a search. It's the QR code will link to a web app, but it's on it's just a simple script on GitHub. It will generate like the SVG pattern, and it's also what it will look like for it, and also a JSON to be put into any other simulator as well. Explanation. It's tricky. Trust me. So yeah, this is just a little interesting thing that I put up there because I thought this would be amazing to create science out
I
of.
feel like that one guy who has to help with the stuff like this. Imagine having to do these kind of paragraph codes, like you see this pattern and then you're folding this paper to get the info.
Holy smokes! That would be a 4-hour long. That would be a 4-hour long escape room.
You could probably make this in 5
Oh yeah, the reason why that's not don't go all the way to the end is because it would basically turn a square origami sheet into a long piece of paper that stays certain kind of that. But if you did have a really long receipt or a really long ribbon, it would probably be easier. I was thinking foil would make it easier. Over here, this sheet is in progress operation. Again, you can see a little E over there, it's formed, and it will be like a doctor's handwriting version of Hackware.
Oh, you tried to fold Hackware.
I printed this on heavy paper, and I'll leave that as an additional activity. Preferably glued down or sandwiched between two heavy stacks of acrylic.
You could probably staple the joints.
Yeah, and it will give it a very nice rustic feel. All right, yes, special thanks to QR codes. Yeah, sorry about the pixel thing. I was hoping that the little error correction would save my ass over here.
I'm guessing your phone, you just do your phone and it worked just fine.
Yeah, I mean,
Somehow, iPhones tend to just.
yeah, our one saving grace is that this is on not a screen, it's on white. So I'm like, maybe the white's enough.
I meant it's just that, was it?
I think the red line around this is just enough to make it work.
You know, I'm gonna go back
Just
to.
to distinguish the QR code from the background.
I'm going back to this dark mode one.
And maybe, as you said, the
It works.
position square, maybe it also doesn't detect it if there's no edge on the outside.
Well, my iPhone has no issue detecting it even when it's really dark. I think in older phones, but this one has like some correction algorithm. Yes, special thanks, my creator of all the QR codes. The Disenchitify project. Have you noticed that every time you want to generate, if you do not have a QR code generator in Python, although you can wang jangle one really quickly, but if you want to create one on the fly, have you realized that every QR code, like the QR code generator, QR code monkey, Google Chrome, every time you create one, it sends it to a redirect instead of sending it to the actual site. That's a really enshittified method of like getting analytics or making it a paid feature or whatever. They say, oh, you can change it afterwards, but that just didn't sit well with me. Luckily, a bunch of developers thought the same thing and then created a series of projects that anyone can contribute to get a enshittified product and make it disenshittified. So yes, if you can scan it,
Maybe the QR code generated should be too long, because very quickly, outside of the error corrections and some of the standard parts, it's just including the ASCII text link into it.
yeah, exactly. That's the pain point. I mean, QR codes are not really that hard in the grand scheme of things, but it's a free, great a feature that has been taken by all those sponsored SEO ads at the top of web pages saying like, oh, use us, we're better. But it adds a bunch of like stuff you did not ask for and bloatware. But yeah. If you can scan it, that's great. Then that means the disinshitified project has successfully disinshitified QR codes. Thank you for listening.
Yeah.